So this is problem here. We've been given a parabola y equals x squared. Okay, parabola looks something like that, vertex there. And that line, S, is going to be, if I rewrite it, it's going to be negative x plus 2. So it's going to give us a line that looks kind of like that. Okay, and it says it intersects at A and B. So there's A and B. We can just solve the intersection of those 2 points, just make them equal to each other. Okay. And then it's a quadratic equal to 0, factor it. We have x equals negative 2, negative 2 here, positive 1 here. Okay, so what we've done is so that's the points. So what we want to do is we want to determine a point P on this line, on the parabola, where we can make a triangle and maximize area. So I'm going to call that point P here. Okay, and we want to make this triangle and maximize the area. Well, the only thing that really can maximize this area is, notice that the base here is fixed. A point P, A, and B are fixed. So the only thing that can maximize this area is maximizing the height of that triangle. Okay, I'm going to call that H. And we want to find some point on this parabola that will make H the longest. Okay, so I'm going to use this formula here. I'm not going to explain how I got this formula, but this formula is the distance from a point, some point, which this is going to be this point P on this curve, to a straight line that is in the form ax plus by plus c. Okay, so that's why we wrote it here. So ax plus by plus c is going to be 1x plus 1y minus 2. Okay, so we've got our a, b, and c's of the general form. So I'm going to set this up then. The h is what I want to maximize. Okay, I'm going to put it into here as x plus 1x plus 1y minus 2, okay, all over a squared plus b squared, which is 1 squared plus 1 squared. So it's all over root 2. So there's my equation that I'm going to maximize. Problem is I can't maximize this because too many variables, but we know that that point P has to lie on this xy equation. So I'm just going to replace the y here with x squared. So now I'm making this h as a function of x. I end up with x plus x squared minus 2 all over root 2. And I'm going to find that point, the coordinate of that point, which will maximize the height, which then will maximize the area. Okay, so differentiating, I'm just going to rewrite this to make it look a little bit nicer. It's going to be 1 over root 2 x squared plus x minus 2, and I want to find out where this derivative is equal to 0. So I'm going to get 1 over root 2, 2x plus 1. Okay, solving this where it's equal to 0, x is equal to negative 1/2. So at x equals negative 1/2, that's going to give me the biggest triangle in that space. Okay, so I think what's the question asking? Find a point P on the parabola. So I found the point X point on that parabola and just plug it back into the parabola to get the Y coordinate. So there it is. And if you want, you can calculate the area of this by actually calculating the length of H and finding the distance between those 2 points, okay, using Pythagoras, and we can actually calculate the maximum area of that triangle.